Hi, in this video we will study matrix powers. If you have a matrix A, can we make sense of A to the power 2, A to the power 3, A to the power 10? Well, the first thing here to know is that when can a matrix be multiplied to itself? So if you have a matrix A, is it possible always to multiply A to itself? We have seen in the examples it's not. And indeed, the condition is that, well, if you have R rows and C columns, the compatibility condition says that, well, you can multiply A to A if the two closer dimensions are the same thing here. Yes, it means that the number of rows of A needs to be equal to number of columns of A. Well, in other words, your matrix needs to be a square matrix. So such a matrix is called, such a matrix is a square matrix. In other words, if we are trying to define matrix powers, the first very natural condition is that the matrix needs to be square. The number of rows needs to be equal to number of columns. And well, there is another notion here that since the columns and rows are the same, square matrix will be called order the number of rows. Instead of saying the dimensions, just order is the word we will use. Okay. Well, that being said, now, well, tell us what is the A square? What does A square mean? So let me start with a square matrix. Let A be a square matrix. Then when someone says A to the power 1, we mean just A itself. A to the power 2 means multiply A to itself, as we did in the numbers case. A to the power 3 means multiply A to itself and then another time. Well, you know, another way of seeing this is you just multiply A squared to A, yes. And in general, A to the power n is you multiply A n times to itself. And as the case for A3, you can say that, okay, I first find A n minus 1, then multiply it by A. Okay? Well, this is nice, but you may say you define all the positive integer powers. How about 0? So how about A to the power 0? Or even you can go one step further and ask, what about A to the power -1, -2? The negative things are negative powers are they are related to the inverse matrix topic. We will study it in another section. But A to the power 0, remember for the numbers, A to the power any number x to the power 0 is equal to 1. Well, non-zero number, yes. So if a number is non-zero, you put it to the power 0, you get 1. Now, A is a square matrix of order n. What does A to the power 0 mean? This is, we set it to be the identity matrix. So identity, oh, what kind of identity is that? Identity matrix of the same order. So if your matrix is 2 by 2, your identity matrix will be 2 by 2. Or if it is 3 by 3, it will be 3 by 3, and so on. So in general, we write the identity matrix by I. And what is identity matrix? So identity matrix of order n. Well, sometimes to emphasize the order, we put n down there, is a square matrix. First of all, it is a square matrix of order n, so it's n by n matrix, and AII, if the number of row and column are the same, the entry over there is equal to 1. If they are not the same, it is 0. So the entries are, for example, I2. I2 has 4 entries. A11 is 1. A12 is 0. A21 is 0. A22 is 1. How about A3? Well, the entries on the first row, first column here, second row, second column, and third row, third column, these are going to be 1. Everything else is 0. And I4 and so on. We have all these. So this identity, the reason that we call it identity matrix, so just one quick property of identity matrix. This is very important property, is that it is identity for the matrix multiplication. So if you have a matrix B of m by n, you multiply it by the identity matrix of order n, you get B back. Or if you multiply just it is defined, you multiply identity matrix to a matrix such that the product is defined, multiplication is defined, then you get back the same matrix. Oh, this is m by n. So identity matrix works like 1. You multiply 1 to any number, you get back the same number, yes? So this is the key and actually characterizing property of the identity matrix. Okay, let's do some examples for the powers. I have a matrix given here. I want to find a squared and so on. So a squared means what? You multiply a to itself. Always you start with square matrix, multiply it to itself, you get the square matrix the same order. So it will be 2 by 2, and entries. So first row, first column. So 1 times 1 plus negative 1 times 2. First row, second column. So 1 times negative 1 plus negative 1 times 3. 2 row 2 times first column. 2 times 1 plus 3 times 2. And then the last entry is 2 times negative 1 plus 3 times 3. And this gives us what? This gives us negative 1, negative 4. 6 plus 2 is 8, and 7. Okay, that's A2. How about A3? Well, A3 means what? You multiply A 3 times to itself, or you already multiplied twice to itself, so you take A2 and multiply one more A to that. So it will be negative 1, negative 4, 8, and 7. Multiply it by the matrix itself. 1, negative 1, 2, 3. This gives us what? This gives us first row, first column, negative 1 times 1 plus negative 4 times 2. Negative 1 times negative 1 plus negative 4 times 3. Then 8 times 1 plus 7 times 2. 8 times negative 1 plus 7 times 3. So the matrix AQ is another 2 by 2 matrix with these entries. So this is negative 9, 1, 1 entry. That is negative 12 plus 1, negative 11. This is 15. And this guy here is just negative 1. Oh, no, not negative 1. It is 21 minus 8. It is 13. Okay, that's a cube. Well, you can have combination of these guys. So 2 times a cube I already have. So it's negative 9, negative 11, 15, 13. Minus a squared we have, negative 1, negative 4, 8, 7. Plus 3 times a itself. What is a itself? 1, negative 1, 2, 3. And minus I. You see, when you don't write order of the identity matrix, it means that all the other terms have the same dimension. And here will be 2 by 2 identity matrix, which is 1, 0, 0, 1. Okay, this, now we have everything here. This is a matrix. The first entry would be 2 times negative 9 minus negative 1 plus 3 times 1 minus 1. The 1, 2 entry is 2 times negative 11 minus negative 4 plus 3 times negative 1 minus 0. 2 times 15 minus 8 plus 3 times 2 minus 0. And the last one is 13 minus 7 plus 9 minus 1. And you compute then the entries. Let me leave it like that, and you can do the rest of this example. Okay, the last piece here, A is 1, negative 1. So let me write it here. 1 and 1 and negative 1 and 2, 3. Yeah. Now, the question asks for A plus A transpose squared. Means what? Means that you have to first find A and A transpose, then multiply it. First add them and then multiply it to itself. So here, A transpose is, you see the first row goes to the first column, second row goes to the second column. And A A plus A transpose then is, well, you see, this is 2, this is 1, this is another 1, and this is 9. Oh, not 9, 6. Just do the entry wise, yes? Now, this means that we have to multiply 2116 to itself to get its square. Here, what we have, 1 times 2, 1. So 2 times 2 plus 1 times 1. 2, 1 times 1, 6. So 2 times 1 plus 1 times 6. 1, 6 times 2, 1. So 1 times 2 plus 6 times 1. 1 times 1 plus 6 times 6. This gives us the 4 plus 1 is 5. This is 8. Another 8. And then 37. That is A plus A transpose squared. So the powers of matrices are defined like the powers of numbers, and the only thing we have to be careful here is that the dimensions of matrix doesn't allow us always to multiply to itself. It happens, it can be done only for square matrices.